Hi, I realized a lot of people don't know this gas law shortcut. So I just wanted to talk about the different gas laws and then show you a shortcut I use so I don't have to memorize all three of these. So this is Boyle's law, and Boyle studied volume and pressure. Okay, so in his experiments, he kept the amount and he also kept temperature constant. Okay, so what he did was took something and studied how if the volume changes, the pressure changes. Okay, and what he found that as pressure increases, then volume decreases, or as pressure decreases, volume increases. And so he found this inverse relationship. So volume is inversely proportional to pressure. Okay, and so as volume increases, pressure is going to decrease. And as volume decreases, pressure is going to increase. And you guys see this when you take a balloon, right? You take a balloon and the gas in there is the same, the temperature is the same, and you squish it. And when you squish it, the sides of that balloon get really, really tight. And so that means the pressure increases. And so if we take this one balloon and look at it under different volumes, right, we can actually calculate the initial, or if we know the initial pressure, we can actually calculate the final pressure using Boyle's law equation of P1 V1 equals P2 V2. Okay, so that's just one of the examples of Boyle's law. For Charles' law, he kept pressure constant and amount. Okay, and so he studied temperature and volume. So here's volume on the y-axis and temperature on the x-axis. Okay, and what he found is as you increase temperature, the volume increases. Okay, and I think the easiest thing to see is like when you have a balloon that's filled and you put it at room temperature or on a hot day and you put it in the freezer, there's going to be some slack in that balloon. And so he found that temperature was proportional to volume. So as temperature increased, volume increases, and as temperature decreases, volume is going to decrease. Okay, and so Charles' law, when we're looking at something that's changing, is V1 T1 equals V2 over T2. Okay, and the last one we have is Avogadro's law. And Avogadro's law is he took the amount of gas and changed that, right? Avogadro's number, he liked amounts. And so he studied what happened when you took the amount of gas and change something. So this is like if you have a balloon and you blow into it, so you're adding more gas. And when you do that, you increase the volume. So here is his graph with volume on the y-axis and the number of moles or amount on the x-axis. And as you add more moles of gas, your number goes up, so your volume increases. And so he found that volume was proportional to amount. And so as amount increases, volume increases, and as the amount decreases or you let it out, then volume decreases. And so with this, with Boyle's law, right, each one of these things have like a proportionality constant that's related to them. And so if we look at Boyle's law, we can say that some constant is equal to P1 V1. Okay, and so that gives the relationship of how the substance changes as we change the pressure. Okay, Charles' law also has a proportionality constant that we're going to call V, and it's going to equal V1 over T1. Okay, and then Avogadro's number also has a proportionality constant where we have V1 over N1 equals C. Okay, so what we can do is combine these three laws into one big one, right? So I can take and say A times B times C. So all of those proportionality constants is going to equal PV over, over NT. Let's see if I can erase this. PV over NT. Okay, and so if we carry out reactions at STP, right, this is standard temperature and pressure. And so at standard temperature, we have 0 degrees Celsius or 273 K. And at standard pressures, it's 1 atm. So this is the definition for gas laws. Okay, standard temperature and pressure, 0 degrees Celsius, 1 atm. Now, if we think about gases in general, if we have 1 mole of gas, that equals approximately 22.4 liters of gas, right? That's about the size a mole takes up. So if we take A times B times C, and we set that equal to standard conditions, we have a pressure of 1 atm, a volume of 22.4 liters of gas, divided by the amount, which is 1 mole, times our temperature, which is 273 K. Now, if we multiply this out, 1 times 22.4 divided by 1 divided by 273, you get this number. That's 0.08206 atmospheres times liters over mole K. And in the gas laws, we actually call this constant R. Okay, so that's a proportionality constant based off of standard temperature and pressure that we get when we're trying to compare all of the pressure, volume, amount, and temperature changes in a system. That's why the units of R are very, very important. If we change any of the units, then the value for R changes. So when we're doing gas law problems, it's really, really important to make sure that all of the units are the same. So the ATMs, the moles, the liters, and the K, everything is the same. Now, a question was asked, what if you have a gas that you're studying under 2 conditions, right? You're trying to blow up a balloon on a hot day, or we want to see how much gas in a bottle's filled. Instead of taking and trying to memorize all of those individual gas laws and see what's changing and how the proportions change, the way that I memorize this is P1V1 equals N1R1T1 divided by P2V2 over N2R2T2. And so the values of 1 are when you have the gas in one set of conditions. And then you change those conditions. And whatever you change is for the step 2 or the part 2. So gas in second set of conditions. So this, for example, is if you have helium gas, one set of conditions is where the gas is in the balloon. The other set of the conditions is where the gas is in a cylinder. Does that look like a cylinder? To blow up the balloons, right? And I can do a specific example about this. But the powerful thing about memorizing this equation is you don't have to memorize all of the different parts of ideal gas laws and combined ideal gas laws, and are using Boyle's law or Charles' law or Avogadro's law or whatever. You just have to memorize this. And then the trick is you cancel out the variables that stay the same. So I'll write that here in orange. Okay, so already when I look at this, like if my pressures change, then I keep that value. If my volumes change, I keep that value. But here, R definitely will stay the same. R, if we have the same units, it's going to stay the same. So that can automatically cancel out. And now our system gets simpler. Okay, if we're talking about the gas with the same amount of moles, then we take and we can cancel out the number of moles. And so instead, like I said, instead of memorizing all of the different parts, we can just think of P1V1 equals N1R1T1 divided by P2V2 over N2R2T2, right? We can think about that. And then here's the important part, cancel out variables that stay the same. Okay, so that's kind of the trick and what I use. I will actually use this in an example in my next video, but this will at least get you started understanding the different gas laws.